Hello friends, welcome to my course on unit testing in ASP.NET Core Web API. In this course, along with the full course, I will also be covering the documentation. I will also be delivering the documentation. This documentation contains all the basic concepts. If you are a beginner to the unit testing and if you are trying to understand where to begin with, so this documentation will help to understand what are the different types of test cases and how to set up the project, and different frameworks and IDEs can be used, and how to write the test cases in the REST API, along with some best practices. This course will also be delivered along with the source code on the unit testing. You will be seeing that I have a REST API called the feedback service. This is my service, one of the microservices which I'm creating along with my project iCode4U.NET. And in this microservice, I have a couple of endpoints, the feedback related to the feedback. You will see get, put, post, delete. So all CRUD operations are implemented in this microservice. And in this REST API, I have created the unit testing projects for each project. So these project structure, folder structure, following the clean architecture pattern or onion architecture pattern. And you will also see the unit test cases are written separately for each project at the API level, at the core level, and also at the infrastructure level. So I've written almost 17 unique unit test cases, which is actually following the best practices, industry best practices on the unit testing. So these three, including the course, documentation, and the source code on the unit testing, will be delivered as part of this full course. And this is my REST API. So the course contents are going to be the basic fundamentals on the unit testing. You will understand what the TDD is, what are the different types of test cases like unit integration functional test cases, and also the load test cases. So you will also understand how to set up your project, what are the different types of packages required, folder structures and file structures. I'm following the best practices, as I mentioned, for creating these folder structure and the file structure in the unit test cases. And along with that, you will understand different frameworks, best frameworks like XUnit, Mock, and AutoFixer, Fluent Assertion. I really like these frameworks while writing the unit test cases, and really user friendly. And also discuss about writing the unit test cases on each project level, along with the debugging your test cases, how to use the Visual Studio Test Explorer, and also follow the best practices. And why do we need to write the unit test case, like benefits of unit test cases, characteristics of good unit test cases. All these things, along with the build and release pipeline, will be discussed as part of this unit test full course. Let's begin understanding what the unit testing introduction. So you might seeing that the code coverage is always associated with high quality of the code. High quality of the code comes with the unit test cases. So that's why unit test case plays very important role when you are creating enterprise level microservice architecture code. So in this course, we will try to understand how to write hundreds of unique unit test cases and automate them using the pipeline. So let's also understand what is TDD stands for. So you will frequently hear TDD. It stands for the test-driven development. Is the approach to write tests before implementing the target code. Meaning you will start with the unit test case, you will make it fail, and then go back to the source code and complete your source code and make sure that your unit test case is passed. So it's kind of a back and forth scenario when you are writing unit test case along with your source code. And also understand the different types of testing. So you might be wondering, how do I approach my testing? So where do I start test cases? So let's understand what are the different types of different categories of testing. Here you have unit testing, integration testing, functional testing, and load testing. So once you understand the underlying concepts behind these types of test cases, then you will be able to take which one is actually more suitable for me and what exactly I need to start initially. That is something you will be able to understand once you are clear on the concepts. So let's begin with the unit testing. Unit tests ensure that the individual components of the application works as expected. That's the point number one. And also unit test involves testing a part of the application is isolated from the infrastructure. So it's not depending on those dependencies. It is actually isolated from the actual infrastructure. That means you are not actually calling your infrastructure source code when you are actually testing, applying the unit testing on the controller action. So unit tests, if you are targeting the controller API controller action method, your test case focusing on the single action only, not focusing on the service or the infrastructure code in the clean architecture. Unit tests do not detect issues in the interaction between the components. So it only focuses on that particular piece of code. Unit tests are generally simple to write and quick to run. So compared to the integration and the functional testing, unit tests are simple to write and it takes less time to write, but it also adds a lot of value. Unit tests are implemented based on the frameworks, like you can use the Microsoft provided MS Test, Mock, or NUnit, or there are different types of other testing tools, but these are the well-known .NET related frameworks. So I'll be using the XUnit and also Mock along with that. So let's try to understand what is the integration test cases, integration testing now. So these integration tests ensure that the components interaction work as expected against to external artifacts, like you might have a database, you might have a file system, you are sending emails. So your unit test case focusing on end-to-end flow, starts from the controller to core and to the infrastructure. So in the integration test cases, if you want to write the integration test case for your project, Microsoft offered a package, the framework called Microsoft ASP.NET Core Test Host. So we can use this tool to write the integration test case. As part of this course, I will be more focusing on the unit testing, not the integration testing, but I can make another video on the integration testing by using the test host server. So no use of fakes or mocks in the integration testing. You will see in the unit testing, you will be using mock objects. You will be using the fake objects instead of, so because you don't want to actually hit the service and get the data or the data from the database. So instead, you will be actually mocking those input objects, but not in the integration test case. So don't write integration tests for every possible permutation and combination of because this is also really hard to maintain. So you have to keep the balance. How many test cases make sense while writing the integration test cases? So because the integration tests access a large segment of data than unit tests, and because integration tests rely on the infrastructure, so you have to restrict and try to write less number of test cases compared to the unit test cases. So I will also have the pyramid chart. So let's discuss the amount of test cases. Before that, integration tests follow this sequence. There are 7 points here. So point number 1, you first actually create the system under test. You often hear the word SUT, stands for the system under test. So you will first configure the system under test, and then followed by your test server client, and then these three AAA pattern, like arrange, act, and assert. So arrange, basically preparing your test setup, test scenario, or test data. act actually invoking the function and then assert validating whether the test case should pass or fail depending on the data coming as part of the act. And then you continue this process until all the test cases are executed and then finally report those results. So these are the 7 rules you will follow when you are writing the integration test cases. As I mentioned, my focus here on the unit testing. So let's jump into the next one, which is the functional testing. Again, functional testing ensure that the application works as expected from end user perspective. So normally you will have to depend on your dependencies while writing the functional testing. Now, what are the different tools you can use? Flex flow run, like BDD, business driven development. These are all related terms on the functional testing. Let's try to understand the difference between unit integration and functional testing with this pyramid. So if you look at the unit testing, the number of unit test case are you can afford more unit test cases compared to the integration and the functional testing. So that's why the quantity of test cases more in the unit testing and then integration and then functional testing. And it is expensive to write. You see, it's little less expensive in the unit testing compared to the integration and then functional testing. So functional testing, to fulfill that the user experience and the behavior of the system end to end, you have to put a lot of effort. So that's why it takes more time for the execution also. So the target for the unit test cases should be always in milliseconds. So if you're running 100 test cases, everything should be under milliseconds. Where in integration test case, you will see the time execution is bumped up compared to the unit testing. And if you go to the functional testing, it will be more time taking. So that's why in my previous point, like you have to keep the number of test cases you want to write, because the test cases is something you can really dig into the deeper and write a lot of test cases. But is it worth writing hundreds of test cases, functional test cases, or the integration test cases? That's what you need to have the good understanding on how many test cases need to be written, so that you will see return on investment on your effort. Let's understand the load testing. So this is the 4th categories of testing. So load test aims to determine whether the system is handling specific load or not, right? There are 2 kind of categories, like again, load test and the stress test. So in the load test, applications are under normal control, normal circumstances. So you will decide how many number of users I want to load during my load test, because you know what the requirement of the system. So accordingly, you will load the number of users. In the stress test, you will try to see in what situation my application will be able to handle the traffic. So application will not run under normal conditions in the stress test. And also you will actually checking the stability of your applications when running under extreme conditions. So during the heavy traffic, you will be able to see how much stress your application can take. It is also often running the long period of time with the same stress. I will be running on 2 hours, 3 hours, is my system is still capable to take that load, and gradually increasing the load in the stress test. So these are some of the points you need to remember or understand difference between the load and the stress. And I used to use the Visual Studio 2019 for writing the web and load test framework. But now I think looks like since 2019, though the load test of the Visual Studio got deprecated. So there are other options, like you can use the third-party tools, Apache JMeter or Apache Bench. So these are the separate, different kind of third-party tools you can go for while writing the unit load testing. So I hope you understand the difference between unit integration function and load testing. As I mentioned, you have to keep the balance while spending your time on the unit testing. So let's focus on the actual demo. Here we are going to write the unit test cases on that API I was talking about. Okay, so I'm back to Visual Studio. This is the project or the solution structure I have created as part of the clean project. Let me quickly run to make sure that the solution is working as expected and before start writing the unit test cases. So you will see a service called feedback service. As I mentioned, for this course, I'm going to use this service and write the unit test cases on these endpoints. I have a feedback. This returns all the feedback. This create, get, put, post, delete, basically the CRUD operation. And I'm going to write the unit test cases on these ones. So since the service is running as expected, so what I have done is created a folder called test. So this is the project folder structure I follow in the REST API. So I have a SRC for the source code, tests for the test. And each project, here there are 3 projects, API, core, and infrastructure. And I have also created with the same naming convention, I have created the test projects and suffixed with the test. So everything you will see test, it's a plural. So make sure that you will also follow the consistency. I've seen sometimes test and sometimes test for singular or plural, but it is good to follow the naming convention so that when you are actually automating in the CI/CD, I'm going to talk about how these are going to be useful when you make it consistent. So what I have done is first I created a project. Let me stop. So go and add project under the solution and name it as a test, and then right click on this folder and add a project. I'm going to add the XUnit project. Here make sure that you type the XUnit and you will see the template in Visual Studio 2019. By the way, I'm using the Visual Studio 2019 to show my test cases, create the test cases. So here you will see the XUnit test project with the .NET Core. Make sure that you select this and click on next, and you make sure that you give the appropriate name as per the naming convention. So this is my name, and then you have to say under tests folder. So it will actually create the project in the right location. So once you have done this, so I've created all 3 projects here already in my along with the API. So I come across this. So let me see. You might have seen that when you are creating the unit test project, the target framework might have been .NET Core 3.1, but my API target framework is .NET Core 5. So make sure that both are consistent. So otherwise, when you are giving the reference, it will not work. So the step 2, you make sure that go to the properties and select the target framework 5.0, or you can click on edit project file and then copy this line from the file, copy this line here. So same thing, I have done the same. So by default, when you create the step 1, you created the project. Step 2, you corrected the target framework if it is incorrect. And the next step, make sure that you will review these 3 NuGet packages are added by default, right? And also give the reference of the project reference. So go to the NuGet packages, add project reference, and select the API in the API project, and go to the core and right click and select the core, and same thing with the infrastructure. So that's the next step. And once you are done with all these, you have to add. I'm going to use the that's all I think. So once you added the references, now I'm going to create the file structure. So let me quickly create the files required for testing. So I'm going to follow the naming convention, as I mentioned, same name as this API. So I will have to create a folder called V1. so that I can write the unit test cases. Okay, so it looks like I already have the folder, so I just deleted. Let me add a folder here. I will call it as V1. I will also add another folder V2 because I'm following the versioning. So I will select the file name here to make it consistent. So I'm going to create the same file name. I will say test. I'm going to add controller test. So let's drag into V1. And also let's copy the same file and paste it in V2. And make sure that the naming convention is corrected here. The namespace, it comes under the V1. Sorry, I think I want to create one more folder called controller and then paste the file under the controller. And now let me correct the namespace. So this comes under the same thing. Let's move into the V2. I think this is already in V2. Sorry, I want to create a folder. Perfect. So I have files created. Is there anything wrong? Parameter is incorrect. I think I messed up a little bit. Let's see, is everything okay? So I want this file name same as the V1, except this should be under V2. Looks like there is something wrong. Okay, so there was some error in the folder, so I just cleaned up, and now you see I created V1 and V2 and the controllers. For example, if I want to write the unit test cases on this controller, so I'm going to add a new class. I can say test.cs, and then what I need is the this namespace X unit. Initially, I need this namespace, so make sure that you add that namespace, and also I need a sample test case, for example. So this should be public. So that's how you are going to add the files in each controller. So if I want to have the same in my V2, let's say this is under V2. So that's how I'm going to add the test files similar to my the project, and also follow the same structure, the folder structure. If I want to write the unit test case under the middleware, I'm going to create the middleware, and then whatever the file I have with the same name and suffix with the test, so that I'll be following the consistency. So I'm done with the API, and the same thing I'm going to do with the core project. In the core, for example, if I want to write the unit test case on the models, I'm going to create a the folder called models. Okay, so again, the same issue. So it looks like in my, let me clear the folders I've already created. I think that's why I'm getting these issues. So let me clear the folder so that it will allow me to create. Now I can say models and also create separate folder for services, and then copy this into here. I don't need outside, right? So I will name it as, I'm going to create a feedback test on the feedback model class. So in fact, you can create I'm adding this to show that you can also create unit test cases on the model class itself. You will be wondering how you will be able to create the unit test case from the model class. So I'll come back on this one. But let me first create all the folder structure and the file structure, and then come back to the unit testing. So now go back to here with the same file name. I'm going to create a file called test. This will contain all the service test cases. So looks like I don't have the X unit. So let me see. I'm sure I should have the X unit added here. Okay, so this doesn't have the X unit. So I need, looks like this is not even the X unit project. So let me create the X unit project. Let me wondering how this is created. So I do see the references. By mistakenly, I deleted some of the references. Now those are set back, as I mentioned. So these are the 3 NuGet packages created as part of the project, Visual Studio project template. And let's see if the project is building as expected. So what I've done is added a folder model and added a test class for that model. And the same thing with the services, I added another file for the services. So that's all. I'm going to write the test cases under the API and core. And let me also add, I might not be able to write the unit test cases in every possible scenario, but let me just create a folder structure so that you understand how you will be writing the test cases. So same thing, I think I already have the repositories folder. So let me delete it and recreate. So that's how I'm going to create. And I will move the class here and rename as per the repositories. I will call that as repository test, and that will cover my repository related test. So let me quickly correct the namespace. So yeah, created the repositories test cases. So I've created the folder structure. That's the demo part I was talking about. As part of this demo, I created the folder. I created the 3 projects for as per the source code, and added the references. So I'm going to use the mock, fluent assertion, and auto fixture, and I will add those references in a minute. And let's go back to our PowerPoint presentation. So here we discussed adding the projects for the unit testing, adding the project references, adding the files and the test cases. And now move into the different types of unit test frameworks. So there are almost a lot of unit test frameworks, but here we will be focusing on the X unit, understand the N unit and MS test, but mostly we will be focusing on the X unit. So X unit is the free open source community focused unit testing tool written by the same team, N unit team, and it is actually now X stands for the different programming language. So more than N unit, the number of subscribers are more, or the downloads are more for the X unit. So even the Microsoft products are actually using the X unit instead of the MS test. As I mentioned, N unit is also the different framework for all the .NET programming languages. And MS test is the default test framework that is actually shipped along with the Visual Studio, supported all .NET framework languages like C#, VB.NET, F#, and etc. And the initial version was actually not open source, but they made it open source in V2 of the MS test. Now let's try to understand X unit, because that's what we are going to use in this course. X unit uses 3 attributes. You will see the fact, theory, and inline. So So fact attribute basically create and perform the unit test related to the parameterless. If you don't want to pass any parameters, so you will decorate the fact attribute. But if you want to pass some parameters, so you have to decorate with the theory. You see the example here. So I have a test case called can add. So it's a kind of a calculator passing 1 and 2, value 1, value 2, and adding those two numbers. So here I'm not passing any parameters, so I can decorate my test method with the fact to run and treat this as a unit test. In the X unit, if you want to pass the parameters, you can use the inline data attribute and decorate all the parameters. So for this add method, test case, I'm passing 1 and 2. 1 is the value 1, 2 is the value 2, and 3 is the expected output when you add two numbers, value 1 and value 2. So that's how you will decorate the inline data attribute, and you need to decorate with the theory attribute so that you can pass the inline data. And you can add multiple inline statements here. And the first statement is the first input, second statement, second value is the second input, and third is the third input. So that has to have the mapping with the test case method. And this simplifies as compared to this one. So these are the three main attributes you will be using most of the time when you are writing the unit test cases. And in my scenario, in most of the scenarios, because I'm using the assert and index, it's not that straightforward. So I will be most of the time using the fact. Now let's talk about the three logical parts of the unit test cases. You will always see AAA pattern, arrange, act, and assert, normally consisting of these three parts. Arranging the test case. So in the arrange, basically prepare the data which will be required for your unit testing. For example, data used for different scenarios. So depending on your scenario, you have to prepare that or arrange the data. Act is actually calling that method which you are actually targeting and then getting the data back. And then what assert will do, compare the expected output with the actual result and decide whether to fail the test case or pass the test case. So you will see in my most of the unit test cases, arrange, act, and assert. So this is the best practice. Please make sure that you will follow this consistency. Now let's talk about the mock framework. So whatever we discussed so far related to the X unit, but this is generic, not just the X unit. Now let's talk about the mock. Mock is actually very famous now. This is the most popular friendly mocking framework because this is basically, you don't want to arrange all your data and write lengthy unit test cases. So in that case, the mock is really helpful to mocking the data so that you don't actually arrange all your data. It basically supports different frameworks. If you are using there are different types of mocking framework like just mock, type mock, Rhino mock, N mock, etc. So depending on your comfortness, you can use, and it pretty much supports most of the frameworks. You can use the N unit or X unit or MS test, but the mock is common for all those scenarios. So basically mocking all your classes, interfaces, and there are some limitations using the mocks, like you cannot do that with the static or sealed classes, but that's the limitation with the mock. Now let's talk about the auto fixture. I have also given the references for each framework here so that you can go back and read the documentation, understand more about this framework. Now I will also be using the auto fixture. Auto fixture is again the open source framework for all the .NET programming languages. And basically the goal is minimizing the arrange phase. As I mentioned, instead of writing a lot of the test data part, so that will be taken or delegated to this auto fixture. So it's a really nice framework which will work with different tools like XUnit or NUnit or MS test, along with the N substitute, mock, or the framework. So again, I have some references to understand autofixture, more about the autofixture before you actually write the test cases. And the last one is the fluent assertion. This is a really nice feature. It's a when you are actually in a common language. If you compare with the MS test assert with the fluent assertion, you will see the real feel about the fluent assertion. It's like a common talking language when you are doing the assertion. So again, I have some references to look at those .NET extension methods provided by the fluent assertion. And when it comes to the IDE, you can, because I'm focusing on the .NET, so you will be either using the Visual Studio for Mac if you are a Mac user, or the Visual Studio Code. So this is a really nice lightweight version of the IDE which you can use for writing the unit test cases. This comes along with the Visual Studio, really nice, comes along with your Test Explorer. I'm going to talk in a minute. Now back to the demo. These are the different test cases. I'm going to write part of the controller actions. So as I mentioned, I'm working on the feedback service. I have the get, put, post, delete, so that once you hook with the pattern, I'm following the naming conventions and the pattern, and then very specially, like, you can write hundreds of test cases, but are they unique? Are they adding a value to the project? So that is more important when you are actually increasing the test case. So increasing the number doesn't matter, but what is the test coverage? So that's what we are going to talk about while writing the unit test cases. So I'm following this pattern, like test method name underscore what should happen underscore when scenario. It's kind of a given, when, then. So given is my method name, here when the data, and then what should happen. So for example, if I go back to my API, so I have, let me open my source code. So if I run, you will see those API endpoints, CRUD operations in the feedback service, the microservice I'm working on, and understand what are the possible test cases I can write when I'm actually working on this particular API endpoint. So when you go to the source code for the controller action, so this is my controller, feedback controller here. If I want to write the test case on the get feedback, look into the different scenarios. Here the different scenarios are if the response, if there are if else condition, easy to understand. So here this is my conditional if else condition, right? So if there is no response, if the response not equal to null, then okay. If there is response equal to null, not found. So I can think of there are two types of test cases I can write on the get feedback. So what I'm going to do is get feedback, that is my prefix, underscore should return okay response when data found. Get feedback underscore should return no, not found when data not found. So these are the two test cases. Let's look at the get feedback API. So my input is ID. If the ID is less than or equal to 0, it's a bad response. That's a bad request. If the response coming from the service is going to be null or not null. If it is not null, then okay response. If it is null, then not found. So now you are following the pattern, right? So there are three possible test cases. If it is 0, return the bad request. If there is a response from the service, then okay. If there is no response, which is null, then not found. So let's go back and write get feedback by ID should return okay response when there is a valid input. Get feedback by ID should return not found when no data found. Get feedback by ID should return bad request when input is equal to 0 or input equal to less than 0. So these are the two different bad request test scenarios. Just for showing various patterns, I've added two, but you don't need to really dig into this level of details to increase the number of test cases. If you are writing less than or equal to, that should be fine. Now go back to the other test case, which I have, create scenario. In create scenario, I can return the created at route. What I have is the create feedback should return OK response when valid request. Create feedback should return bad request when invalid. So here I have the bad request scenario if the model state is invalid. So those are the two possible scenarios you can think of in the create feedback. Now let's look at the delete feedback. So delete feedback, now I have to go to the code. I have the bad request. Again, I have no contents and not found. So three scenarios. If you look at in the delete feedback should return no contents when deleted a record, should return not found when record not found, should return bad response when input is 0. Same thing with the update scenario. So update scenario has 4 test cases. One is on the bad request and OK response not found. So I think, yeah, the bad request came twice, just like here, but you don't need to add twice. So this, you can think of 3 unit test cases. So this is almost like, the number coming, how many? So I might need to count that, but so that's how you can think of when you are planning to write the test cases. So now go to the demo, and I hope you understand the naming conventions I'm following and the amount of test cases you can think of when it comes to the number of test cases. Now let's start writing the test cases on the API endpoints. So as I mentioned, I am using the auto fixture. So let me go and add the NuGet packages, required NuGet packages here. So I will install the auto fixture. Make sure that you select the NuGet org. So while that is installing, I also need the mock and the fluent assertion. So these are the 3 NuGet packages I'm going to add in my all 3 projects. Okay, so excellent. So now I'm going to build the solution to make sure that after adding these 3, does it uninstall? So let's build the project. So if there are any compatible issues, you will see the installation, after the installation, if the build is not working as expected. So what I'm going to do is, now if you go and check the packages, I have auto fixture, fluent assertion, along with the mock. So these are the 3 frameworks I'm using apart from the XUnit and XUnit runner. This is running the test cases and the Microsoft.NET Test SDK. So I will do the same in the other 2 projects and then come back. Okay, so now I've added all the required NuGet packages. Let's build together and make sure that auto fixture, fluent assertion, and mock, along with the other NuGet packages, are available. Auto fixture, fluent assertion, and mock, and same thing with the infrastructure project. Perfect. Now I'm also able to build at the folder level. That means all my 3 projects are getting built successfully. So what I'm going to do, I'm going to start writing the unit test cases on the controller file. So what I need is the using statements. So I'll quickly add the using statements. Those three using statements I'll be using while writing the unit test cases. So let me add using statements. Now, if you look at the flow for the controller, this controller talking to the service, right? And then getting the data back. So when I'm writing the unit test case, my system under test is the controller. So this is my system under test. But inside that system under test, I'm also calling the service. So I have to skip that service, make sure that I'm not writing the unit test case, a unit integration test case. So in order to bypass, to make sure this method is not getting called, so I have to set up the mock and then fake it that object invocation and then write the unit test case accordingly. So that's the difference between the integration testing and the unit testing. So when you're writing the unit testing on this particular controller action, make sure that it's not integrated. That means it is not going inside this method when the test case is executed. So how do you make sure that it's not going inside? Let's go into the add those things here. So first thing first, what I need is the auto fixture in my class. So let's create the auto fixture, the read-only property. And I also need another property for my service. So I will be creating the service mock. So let's add the using statement for the service. And then I will also require the system under test, which is my controller. So I'm adding so this is under the V1. So make sure that you will not be confusing. So these are three properties I'm going to use, and then decorate those three in your, so I need the constructor to create the instance of those things. So I'm creating the instance of the fixture, which is coming from the auto fixture. As I mentioned, the auto fixture basically going to reduce your assert component, so which we will be discussing in a minute. Now, this one auto fixture dot freeze. So what is going to do is it is actually going to create the instance of this iFeedback service interface, and then all the underlying plumbing is taken care by this fixture.freeze method for iFeedback service. So you have complete instance in this mock. Now I'm going to have the system under test for the controller. So this class is targeting the controller. So that's why I called as a system under test. Now create the instance. I need to pass the service class. So if you go and look at the parameters for the constructor, I need to pass the service class. So you need to say the service property name dot objects, so that it will actually create the implementation in memory for that particular controller. And then let me write the unit test case. So I'm going to copy paste before I copy paste. So this is my method name. Get feedback should return OK response when data found, as discussed the naming convention. So since my controller actions are asynchronous pattern, I also need to follow the asynchronous. Otherwise, I will be getting the warning. So in order to follow the asynchronous instead of void, I'm going to decorate with async task. So that required a namespace. Just add that. Now I'm going to add those three statements we talked about: arrange, act, and then assert. So in every test case, I strictly following these three. even though if it is not required, you will have to see which scenario not required. But in my case, it is required, always required. So I will decorate like that. And then I'm going to arrange this. So in order to arrange that, what I need is let me copy the service part first. So the service dot setup and the method name and the return type. So let me first fix the using statements. So what I'm trying to do here is I'm trying to create a mock for the collection of feedbacks, and which is going to be return return. It is going to be passed in the return. So in this service, if I go to my controller, what I'm going to say here, if the controller, the unit test, when the unit test case calls the get all feedbacks, this returns the collection of IEnumerable feedbacks. So I'm faking that here, telling the unit test case, when you see this method, get all feedbacks method, just return this mock object or the fake object. So that's my setup here in the service instance setup. So you will see a number of methods getting triggered in that particular system under test method, and you have to decorate with that setup here so that it will bypass the actual invocation. So it will not call the method when you are actually setting up these kind of things. Now I'm going to say all get feedback. So get feedbacks here is the controller method. Get all feedbacks here is the service method. So service method, I'm telling explicitly that return the mock object when you see this method inside the controller action, and then call the controller action. So this is the syntax for the asynchronous pattern. So when your unit test cases are, when your source code is actually following the asynchronous pattern, so you will decorate async tasks and await statement, and then configure await false. So these are some of the best practices. I will not be going details about the the performance of the asynchronous, all those things, but I'll just giving the details here. Now in the assert statement, I'm going to use the fluent assertion. So normally you will do assert.not null and then pass the result. So this is the MS test or the XUnit way of asserting. So I'm not going to use this kind of syntax. Rather, I will be using the fluent assertion. The same line of code, you can call it like this: result dot should not be null. So it's like a readable format. As I mentioned, it's a friendly readable language. That's why I'm using the fluent assertion. So on top of that, I can also say result should be assignable to my action result of the type IEnumerable feedback. So that's my response type. When result comes here, I'm saying that it is assignable to collection of feedback. And then I can also say that my response category. So result should be assignable to OK response. That's the status code related assertion. And then you can also write in one line. So the result as OK response, the value should not be null and be of the type mock when the data coming back. Finally, I'm going to use the verify syntax, which is of the mock framework's verify syntax. When this service method gets called, making sure that this is verified and getting called or the bypassed as part of this test case. So this is how you are going to add your assertions in your test case. So this is the test case on the get feedback. Now let me also add, I'm not going line by line this time. I'm going to copy paste the already written code here. Get feedback should not found when data not found. So this is a negative scenario. So it's the same setup here. You will see here my response is null. So I decorated with list of all the feedbacks I'm passing as a null to the method. So if I go to my method here in the service, basically inside the repository, if I don't get the data from the database, I'm going to return null. So that's the scenario I'm trying to address in the test case. I'll be passing the, I'm telling that my controller action when God calls this method, return the null response so that I should be able to assert not found assignable type. So this is about the negative scenario. Now let's take a look at the other test case on get feedbacks by ID. Should return OK response when valid input. So this is my valid input. I'm mocking or faking the object and passing and telling my method that when you get called get feedback by ID, you return this feedback mock. So that I should be checking the positive response. So this is invoking your controller method by passing the ID here. So again, ID, you can hard code the value here, but I'm again using the auto fixture create. So what this will do is it is actually create the random number, generate the random number assigned to this property and pass as part of this input. And then in the system under test, when it is called, getting the response and the response not null and assignable to, because this is not the collection as compared to the previous one. This is returning only one feedback based on the ID. So I'll be decorating with action result of feedback, and you can also check the status code result, OK response one. And then there are two properties. There are two status codes you will see here. One is OK result and OK object result. So if you are emphasizing on the object, so you can use the object result. Otherwise, you can also say OK result itself. And the last one, checking the type, and finally verifying, making sure that your method, service method is getting verified as part of the unit test case. So that's how you are going to increase the number of test cases. So let me add another test case on the get feedback by ID. Should return not found when no data found. So it's kind of the same thing, but the status code is different here. So I'm passing the null so that my service will return null, and then I can use the assertion to verify the null. And then there is a negative scenario in this feedback by ID. What if my ID is less than or equal to 0? So in this case, I can validate my response should be bad request. So should return the bad request when input is 0. So I'm explicitly passing 0 here to my service so that it returns the bad result, and same thing with validating with the bad request result status code, and then finally verifying. So if you want to increase the number, you can add minus also. So as I mentioned, so it's really not required. I just, for the demo purpose, I'm adding here the another test case just to show that how you can increase the number of test cases. And then when it comes to the create, should return OK response when valid request. So if you look at here, I have a bad request, I have a valid one. So I'm focusing on the valid one. So I will be checking the status code created route at result. So you will see different status codes as part of the Fluent assertion. So make sure that you are picking the appropriate one to assert the result. And then you can also have the bad request scenario. So that's how you can add. It's kind of a repetitive, right? So this is interesting here. So what I'm doing, part of the create feedback, you want to make sure that your test case is actually going inside here, so that you will get the bad request. So I have to explicitly update the model state. It's kind of hacking and add model to the error. Like, it's the subject saying that there is no subject pass and subject is required. So if you want to debug, put a breakpoint here. I'm going to show you how you can debug the code. So let me also put a breakpoint here, and then you will see right click and debug test. So for the debugging, the easiest way always press the Control R and Control T. So you can debug. What it will do is, first it will build the code, because I think I keep adding but not run any test case so far. So it's going to build first and then trigger the test case. So since I clicked on this, my controller is on this particular test case, so only this test case will get triggered. Now I see the breakpoint coming. I'm going to step in F11. So I came here and then see it is going inside the model state, because I added the model state invalid. Now my API endpoint returned the bad request. So I'm going to validate, make sure that I got something not nullable and also assignable of the type bad request, and finally verify that method is get triggered. So my test case is fault. Same thing, if you want to run the test case from here, you can just run the test case, or you can debug the test case. So those are the two options you can see while running the test cases. So that's about the create method test cases. Now let me add another test case on the delete. Delete should return no contents when delete a record. So you will see that the delete. This is how you will be testing. So I'm telling my service method return true, so that it actually got deleted, and then it should not be null, and it should be assignable to no content result. So that's how you can validate the positive test case. And then next add the negative test case, which is if there is no record, I'm faking here saying that return false. So when it returns false, it's going to be not found status code. So let's quickly run the test case to make sure that the test case is working as expected. Yep, so it's green. That means the test case is working as expected. So the other test case here is the bad request scenario when input is 0. So I'm passing the input as a 0 and telling that return the bad request. So that I can validate the bad request scenario. Let's quickly run to make sure that the test case is green. Perfect. So that is green. That means the test case is working as expected. Now moving to the update scenario, should return the bad request when the input is 0. So I'm passing the input 0. So in this case, I need two properties, ID and the object. So the object, I'm actually using the fixture one so that I can mock it, and then expecting the response as a false so that I can check with the bad result. So let's quickly run this. Okay, that's green. Now moving to the next unit test case on the feedback, should return bad response when there is an invalid. Same as the create. So I injected here the model so that it is actually go inside the bad request scenario. When the model is invalid, go here and then I can also write the unit test cases on OK and not found scenario. So that's how you can increase. So I'm just going to just add the remaining 2 test cases on the update and then move on. So these are the different types of test cases. So let's quickly build the API test and start using the test explorer. So once the code is built, you will be able to see that the test explorer is part of the Visual Studio. It automatically detects all your test cases written in the test projects when you build the code. Now I see there are around 16 test cases being added in the API projects. Now let's take a look at the different properties here. So if you want to run all your test cases, just click on all your test cases. As I mentioned, it will first build, and step 2, it will run the test cases. Now, if you look at all 16 test cases are executed under 270 milliseconds. That's that fast the unit test cases. So so make sure that you will also see the unit test cases should not increase the time span should be really less, like even the single digit milliseconds sometimes. So let's quickly take a look at here. You see here, if you see it is taking a minute, if you're taking seconds, that means you are doing something wrong, or you might be doing the integration testing, not the unit testing. So make sure that all your unit test cases, the time span is really, really small. So that's how you can add the unit test cases at the controller level. Let's go back here. And we looked at the test explorer. As I mentioned here, this button you will use for running all the test cases. This button, you can use it for running the selected test case. So let's me, if I want to run this particular test case, so I can select that and run that particular test case only, not all the test cases. So if you see, that's the only test case screen here. So that's how it runs. Now repeat the last test run. So you can quickly want to trigger. So sometimes when you are working on the code, so it might fail for the first time, and then you want to rerun using this tool. So it's easy. Now, more than that, I think I find this tool is really helpful for debugging and running the test cases. So if you want to run only failed test cases, click on here, and also you can look at the number of test cases. I have 21 test cases. The filter passed versus the failed test cases. So there are out of 17, there are 6 passed and 5 failed, and these are kind of not run yet. And then you can also, sometimes if you have written thousands of test cases, so it's good to see the search tool. So you will also have the search tool. So you can expand this, and you can say, so if I want to search with the bad request, for example, so just filter that I have 3 test cases with the bad request. So that's how you can search and filter. And then you can also see different other options, like I think creating the playlist filter, and also some test settings here. If you click on the settings, you can add more columns, for example, class name or the namespace or the project name if you want to see. So those are the kind of settings options. Will open the options available. So that's how you can use the test explorer. Now move on to the benefits. So let's talk about the benefits of unit test cases. You will see less time in performing the functional test. So unit test, I think, compared to the functional test, it is going to take the lesson time. So as I showed, like it normally takes the milliseconds to run the unit test cases. So as I mentioned, if it is taking more than a minute, more than in seconds, even in seconds, you have to look at that something wrong in the test cases. Protection against the regression. So regression tests are kind of regression defects are defects that are introduced when change is made to the application. So you will always fear that when you are modifying the code, if you are not confident whether this code will work in the production or not. So you can kind of avoid adding the more and more unit test case. So it basically boosts your confidence when you are writing the unit test cases along with your source code. So it really will not add and avoid the complete defects, I would say, but it is actually going to check the quality of the code, and you might see real incident issues coming up when you are adding hundreds of thousands of test cases in your system. It will definitely add the value to the regression test cases. And executable documentation, meaning, as I mentioned, my test cases are in the kind of a BDD given when then format to understand if you are doing the manual testing or the functional testing. It will help you to understand at least for the testers, they are not very close to the code. So by looking at the unit test case, if you generate the report and give it to them and they're looking at that documentation, they will be able to understand what your API actually doing, what are the possible test cases they can actually do during the functional testing. That's about the executable documentation. And the next one is the less coupled code. So this is you are automatically forced to organize your code better when you think through the unit test cases. So naturally you are decoupling your source code and you are writing the layered architecture code automatically. Now let's take a look at some of the characteristics of the good unit test case. So because everybody wants to write the unit test case, and I've seen most of the time the developers mess up the unit test case, not following really the best practices. Point number one, it is fast. It is not, make sure that it is sometimes taking a lot of, I've written test cases and taking a lot of time. So those are the kind of complaints I've seen from the developers. That means they are not actually writing the unit test cases, or they are not actually following the best practices. As I mentioned, so it is always should take less time when you're writing the unit test cases. And isolated, so make sure that they are all standalone and should not depend on any infrastructure part like a database or the file system. And it should be repeatable. So every time you run, it should have the same response. So it should not keep changing. If you are restore the database and my test cases are start failing, that means that's not the unit test case. So that's not following the best practice. So self-checking is like, it is always without human interaction. You are running these test cases on the CI/CD pipeline and make sure that those test cases are triggered along with your build. So that's just kind of a self-checking. And also, it should not be taking a longer, because if you are going to keep these unit test cases along with your build, if the build is taking 3 minutes, 4 minutes because of the unit test cases, that means those are not following the best practices. Now let's take a look at the naming conventions. I think I emphasized about the naming conventions which I'm following. So name of the method and the scenario and then expected behavior. So these three characteristics should be shown in your naming conventions when you're actually writing the test cases. So as I mentioned, I have also giving the documentation along with the source code and the video about all these about the unit testing. So you will be seeing this along with the source code, and finally you will also see the references which I have followed for coming up with this video, all these things. So you are going to see this documentation along with the course. So I think I'm not done yet. So I have to create unit test case. So I've completed the unit test cases only on the API. Now let's do a demo on the writing the unit test cases on the service class. So in order to write the unit testing on the service class, so this is on the core project. So let me open my core services where my business logic is actually sitting. So as part of the clean architecture, my controller calls the service and service calls the infrastructure part. So I'm going to create a unit test case on this create feedback service class method. So here I will be handling, try catch block and also some of the business logic calling the, the helper methods and etc. So since my use case is very straightforward cloud operation, so I don't see any business logic layer here. And then here directly calling the repository where my source code is located. But most of the time you will be seeing a lot of business logic in the service classes. So you will have to write the heavy number of test cases in the service classes. So let's go back to the service class. As I mentioned, there are three things I need to add in the using statement for writing the unit test cases. Along with the X unit, I will have to add the auto mapper, mock, and the fluent assertion. And then I'm going to use the fixture. So I'll create a property on the fixture and then create the instance in the constructor. So let me add constructor here and then add the fixture instance. And I will also need the repository because the repository is going to call in the service. So I will add the repository here and also create the mock instance for the repository, say fixture.freeze and the interface name so that you will get all the instances of that repository. Now I'm also using the, if you look at my service class, constructor required two parameters. One is the repository and the second one is the logger. So let me also mark the logger and then create the instance of the logger in the constructor, just like your service. So I also need iLogger, which is the Microsoft extension logging. Perfect. Now I need the SUT, which is the target class. My target here is the service, which is the system under test. So I will have to add the system under test instance here. So create the new instance of the service. There are two properties like repository and the logger and pass those two objects. So that's all I need part of the constructor. Now I'm going to add a test case for the get all feedback API endpoint. So let me replace this code. So I've copy pasted the code which is already written. So since this is my asynchronous operation, I need the async task along with await and configure await with the false statement for boosting the performance. Now I'm going to add the using statements here so that the code is happy. It's the same concept. You first arranging the mock class here so that I can pass it to my repository method. Here in this case, it's a repository and return type is going to be the mocked object. I'm saying that when I call this repository method, I'm in the repository. Repository method, it returns the fake object so that my service method should have that expected output. Once I got the response, I will be using the fluent assertion we already discussed, checking the not null assignable to collection of objects and verifying the object. So it's a same pattern I'm following. So let me add another scenario. This is the positive testing, and then this is the test case when there is no data coming. So I should be testing not null in case of no data found. If I go to my repository, so I will be getting the null, right? So I'll be asserting with the null statement, and this is verifying the method name is correct or not. So same thing, I'm going to add test case for the get feedback by ID, positive test case, which is same as assignable to. So here I'm not using the HTTP status codes because this method actually returns the object. So here returns the collection, here returns the object. So that's how I will be adding here. And the next test case on the ID, again, the variation here is should return null when data not found. So I'm actually returning explicitly null so that I can assert with the nullable object. Same thing with one more test case on the get feedback by ID. This is interesting. This is another variation. Should throw null reference exception if you go to my method here. So I think I need to add another condition here. So let's say if the input is less than or equal to 0, then throw this exception. So I want to I added this condition so that I can also validate my inputs at the service level. That means, as I mentioned earlier, every if-else condition coming up as a unit test case. So to fulfill the this requirement, I'm going to say should throw null reference exception when input is 0. So the input is null for my repository method. So here I have to use the func syntax to and also remove the async task await method to actually use this throw argument null exception of the fluent assertion. So make sure that you understand this particular unique test case. So I will emphasize on the null reference exception using the func syntax and getting the response, and this result is going to be asserted through the null reference exception. So in order to assert using the fluent assertion for the exception, and that's the reason I had to use this particular syntax. Now going back to the create, let's see, should return the data when data is inserted successfully. So I'm passing a fake object, and the repository should return a data, and then I will be validating assignable to feedback. So that's a pretty straightforward. Now let's take a look at the another scenario. Here again, the null reference syntax, no async calls. I will be using the func syntax so that I'll be able to check the null argument reference assignable. Another test case on the feedback, delete feedback should return true when it is deleted successfully. So it's a pretty straightforward. Only the difference here is it's returning true statement. Now let's take a look at the false scenario. What if my repository returns false? So this is my repository returns false. I will be asserting through the false statement. Now let's take a look at one more scenario on the same delete. This time I'm going to say the null reference exception. So if I don't pass the input ID, again, just like the get feedback by ID, you can also do the null reference exception. So in that case, I make sure that if I go here, I should be adding the this condition so that my test case actually will work as expected. Now let's look at the update scenario. In the update scenario, again, successfully updated should return true statement, and if it is not updated, then return false statement. And if there is an exception, then it should throw the null reference exception. So in that case, again, I'm going to add the condition because this one required ID, and also I'm going to add what if my input object is also null. So there are two such scenarios. As I mentioned, every if-else condition, you can think of writing a different test case. So in this case, I can add null reference exception for ID equal to 0. I can add null reference exception for the actual objects. So let me add one more test case for the actual object. When the object is passed as a null, I'm passing the null object in the request so that it returns the false. So since this is a null reference exception, so I will not be having the asynchronous pattern. So that's how you're going to add and increase the number of test cases at the service level. So let me quickly build so that my test explorer will pick up those test cases. Perfect. So now if I go and run all my test cases, so around 20 test cases I've written so far in the API and core. Let's see if everything is passed. So now I can see all my test cases are passed. So some reason I think there is something wrong. So the other project is not showing here. Something wrong. Okay. So that's how you are going to write the test cases. So I will not, I think, as an exercise, I will leave for the writing the test cases at the infrastructure level. Let's go back to the presentation. So we talked about this, So I think I'm pretty much done for this course. So this is a long course. Yeah, so I covered only the unit test cases as part of this, but you can also think of writing the integration test cases using the Microsoft test server. So that will be my another video, how to write the integration test cases and also the functional test cases using the BDD spec flow runner. So I'm also making more videos on the .NET Core 5 REST API architecture. So this is kind of a step-by-step guide. It's not just the theory. You will also see the practical actual implementation where you can write the code in the enterprise level applications. So I started my series with the fundamentals. Here I discussed about the basic concepts of the clean architecture fundamentals. So this is complete theory video. I have this video on the YouTube. So I talked about all the solid principles and along with project structure, etc. for the onion or the clean architecture. And in my second chapter, I discussed about the project structure. So the project structure, which I'm talking about, this one, how I created this project structure as discussed here. You will see really a lot of files have been created, followed the industry API, REST API best practices. So these are my table of contents in the chapter number 2. And then in the chapter number 3, the API configurations like, auto mapper, using all the best practices for creating the files, and also talked about logging, exception handling, Swagger configuration, and following the versioning. All that is discussed in the API configuration. In a separate video focused on the Azure Key Vault health check, that's my 4th video, and these are the topics. So I've used the Azure to pretty much here for configuring the Azure Key Vault and also running the health check. So if you watch this video, you will know more about the health check. In my 5th video focused on the entity framework code, CRUD operations, with the SQL, and these are the contents. And then finally, I think discussed about before this. Yeah, so this is my sixth video focused completely on the infrastructure side, creating the DevOps pipeline, creating the Azure services, and deploying the API directly from the Visual Studio, and also created the DevOps pipeline and automated the API and SQL projects in this course. And in my previous one, discussed about the API best practices. So creating the API is one hand, but following the best practices is something really required. So I discussed about the API versioning, giving plural names, naming conventions, and status codes. Especially the status codes is something really important when you are actually creating the unit test cases. So these are the different topics discussed as part of the journey. I hope this video is helpful, and I will be coming up next with the another topic I will pick up probably on the security side, authentication or authorization. Thank you very much for staying with me such a long time.